Hey guys, it's Lorenzo here. This video is for our laminar flow project for our fluid mechanics class. So like all great experiments, there's usually a bunch of trial and error that I face myself, so bear with me as we go through this, but I think I've gotten pretty close to nailing it just about right. So I'd like to start off by asking the question, well, what is laminar flow? So the best way that I would describe laminar flow is basically a fluid that's flowing so smoothly that it doesn't even look like it's flowing at all. When you look at the fluid, it looks almost like glass. So if you look at this picture here, I think we covered it really well in class. Essentially, you have your three different flows going on. You have a turbulent flow, a transitional flow, and a laminar flow. Turbulent flow is really sporadic and real chaotic, and there's like a lot going on where the fluid doesn't look it's really streamlined at all. And then you have your transitional flow where it's wanting to be laminar, but it still has some turbulence going on in there. And then you have laminar flow, which is just a very beautiful straight line where, again, the flow looks just like glass. So to find out if you have laminar flow, ideally you'd be able to tell just by kind of looking at the flow of the fluid. But there's also a calculation you could do to find your Reynolds number, which I'll show here in a bit. But ideally, if you have your Reynolds number between 0 and 2000, that's when you have your laminar flow. Once it goes from 2000 to about 4000, then you have your transitional flow. And finally, if you were to have your fluid going over 4000, that's when you're at a point where you have a very turbulent flow. So when I first started this project, I had an original idea that I had gone with. Essentially, I was trying to make laminar flow out of a PVC pipe by slowing the water down a certain amount. And like I said before, all great experiments, there's a lot of trial and error. I worked at it for a while and I got what I thought was laminar flow. It's only until I came and tried doing the calculations that I sat here for a good while trying to get the calculations done, and just to find out, well, that wasn't really laminar flow. So I went, out of my frustration, I went down, I got a drink of water, and going to my realization, well, hey, there's laminar flow right here. So if you look at this picture here, these are the numbers that I came up with to go ahead and calculate my Reynolds number. Reynolds number is going to be rho VD over the viscosity. So I went ahead and calculated the area by taking measurements of the discharge orifice. I got the flow rate by taking a 2-liter container and timing how long it takes for this flow to fill up that container. From then, I went ahead and just did my calculations to get velocity. I plugged in all my numbers into the Reynolds number equation. Figured out that in the house, it's actually 20 degrees Celsius, so I did that and was able to go onto our table that we were provided in the textbook and plug in all the necessary values to come up with a Reynolds number of 2092, which is less than 2100. And last but not least, here's the video of the actual laminar flow that I found. If you look at the flow itself, it looks, like I said before, real glass-like and real nice and smooth, as if it's not even flowing at all. And then what I try to show here with the laser pointer is that when the light from the laser pointer hits the flow in a certain way, it refracts onto the back wall into like a straight line kind of situation. Whereas here in a second, I'm showing the turbulent flow off a regular faucet, and when the light hits that, you can see in the back wall where it's real turbulent. You can see the laser being refracted multiple times. It's just kind of moving around. It's kind of chaotic. And then I go back to our laminar flow over here, and again, it's real streamlined, and then the light is being refracted in a way where it's like a straight refraction into the background, and it's actually pretty interesting to see. So this is the end of my video. I hope you guys have enjoyed it. This definitely was a very interesting project and fun to do, and I'm just kind of glad I found that laminar flow at the end. I know there's probably a few things I probably could have added into the video, but as you guys probably found out, video editing is a little bit harder than I realized anyways. But I hope you guys, again, I hope you have enjoyed it, and thank you for a great semester.